Hey guys, welcome back to Eureka, and in this video I'll be teaching you some properties of the derivative function. So we defined the derivative in the last video as the limit as x goes to 0, f of x delta x minus f of x over delta x, right? Now, we need to prove some properties of this function. In the book it tells you, and this property is called the power rule. Power rule. If you have x to the power of n, then the derivative of x to the power of n is equal to n multiplied by x raised to the power of n minus 1. Alright, and I'm going to take two functions, let's say x squared, and I'm going to prove it with x squared, then I'm going to prove it with x cubed, and then you guys will see the general formula as x goes to the power of n. Sorry about that. So in this case we said f of x is equal to x squared, right? So we can say f of x plus delta x is equal to x plus delta x squared, right? If let's just substitute this into the derivative formula. So it's gonna be x plus delta x all squared, right, minus f of x, which is x squared over delta x, right? And the limit as delta x goes to 0. So let's expand this term and let's solve the equation. This is equal to the limit as delta x goes to 0. Well, x plus delta x all squared is equal to x squared plus 2x plus, sorry about that, sorry about this. So plus 2x delta x, right? Plus delta x squared. And all of this is minus x squared over delta x, right? So let's simplify this. X squared minus x squared equals to 0. So this will cancel out with this, right? So we have 2x delta x plus delta x all squared over delta x, right? And we say the limit as delta x goes to 0. Now let's factor out delta x. Now we can't apply the limit definition. We can't say delta x goes to 0, because if delta x goes to 0, then this becomes 0, right? And we can't really divide by 0. So what we're going to do is we're going to try to remove that denominator. And how do we remove it? Well, let me show you. We can factor out delta x from the numerator. So we'll be left with 2x plus delta x, right? Over delta x and the limit. So delta x cancels with delta x. We will be left with the limit as delta x goes to 0, 2x plus delta x. Now, we can apply this limit definition now, because we don't have a denominator. And we can say, okay, as delta x goes to 0, it becomes equal to 0. So 2x plus delta x and with the limit is equal to 2x. And we proved that the derivative of x squared is equal to 2x. Now let me prove that the derivative of x cubed is equal to 3 multiplied by x squared using the power rule, right? So using the power rule. Now let's say that f of x is equal to x cubed, and well, f of x plus delta x is equal to x plus delta x all cubed, right? Let's substitute it into the derivative. We're going to get x plus delta x all cubed minus x cubed over delta x, limit as delta x goes to 0, right? Let's factor out the numerator. We can factor this. Remember the binomial theorem? I showed you a video earlier, not today, but like on the YouTube channel. And let's factor this out. It's going to be x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed, right? Minus x cubed over delta x, right? Now let's simplify the numerator. As we can see, we have x cubed and minus x cubed, so they cancel out, right? So let's rewrite this. We're going to be left with this, delta x squared plus delta x cubed all over delta x, and we have the limit, right? Now, as we said, we can't apply the limit just yet because we have a denominator. How can we remove it? Well, as you can see, in the numerator we have 1 delta x, 1 delta x, 1 delta x. So we can factor it out and we can cancel. So let's factor it out so we can cancel. So we have the limit as delta x goes to 0. And we say 3x squared plus 3x delta x plus delta x squared. And we factored out delta x, right? Well, this cancels with this. We're going to be left with the limit as delta x goes to 0 of 3x squared. Let's just remove this. 3x squared plus 3x delta x plus delta x squared, right? Now we can apply the limit definition because we don't have a denominator. So as delta x goes to 0, delta x will be equal to 0, right? So this becomes 3x multiplied by 0, and this becomes 0 squared. When we sum up the 3x squared, this does not have a delta x, so it does not get affected. These cancel out, and we're going to be left with 3x squared. So the derivative of x cubed dx is equal to 3x squared. And if you look at the power rule, the derivative of x to the power of n is n multiplied by x to the power of n minus 1. So x cubed is going to be 3x to the 3 minus 1, which is equal to 3x squared, right? And that's the power rule. If you have x to the power of 4, if you have x to the power of half, if you have x to the power of negative half, you can always apply this rule. And it will always work. And in this video, I kind of proved it. And hopefully you understood. So now let's do one exercise so you guys can get the general idea. Let's say we have y is equal to x cubed over the cube root of x, right? Let's say we want to find dy dx, which is the derivative. Let's rewrite this. So we can say it's x to the power of 3 multiplied by x to the power of minus 1 over 3. Because, you know, the cube root of x is the same thing as saying x raised to the power of 1 over 3. And 1 over the cube root of x is the same thing as saying 1 over x to the power of 1 over 3, which is the same thing as saying x to the power of negative 1 over 3, right? And now we can use the exponent rule, and we can say that, okay, it's x raised to the power of 3 minus 1 over 3, which is 8 over 3. Right? So we can say that y is equal to x to the power of 8 over 3. And let's apply the power rule. If we have x to the n, then its derivative, derivative, is n multiplied by x to the power of n minus 1, right? So here, to find the derivative, we bring out 8 over 3. And we can say that 8 over 3 minus 1, right? And you can use a calculator, and this will be evaluated to 5 over 3. And that's the derivative of this function. So now we're going to be moving on to the next property of the derivative, and it's called the polynomial property, or the addition property. Let's say you had a function. And it's equal to the sum of two other functions, g of x and k of x, two other functions, or actually any number of functions, g of x plus k of x plus u of x, but I'm just going to prove it for two functions and just to generalize. So the derivative of dy dx is equal to the derivative of the first function plus the derivative of the second function. Pretty easy rule to memorize, right? If you have y and it's equal to two different functions, then the derivative is going to be the sum of their derivatives. But now let's prove it. right? Let's prove it. Again, we're going to be using the definition of the derivative that we acquired from the derivatives video, which is the limit as delta x goes to 0, f of x plus delta x minus f of x over delta x, right? And now let's just substitute, and we can say the limit as delta x goes to 0. And in this case, y is equal to f of x, right? And f of x is equal to g of x plus k of x, right? Now f of x plus delta x is equal to g of x plus delta x plus k of x plus delta x, right? So let's just substitute. So this and this are equal, so we can say we have g of x plus delta x plus k of x plus delta x, right? Minus f of x, minus f of x. And f of x is g of x plus k of x, right? All over delta x, right? So now let's do some mathematical magic, and we can do this, right? All I did was I rearranged, and I'm nearly done. All I did was I rearranged these terms. And now let's factor this fraction out. X plus delta x minus g of x over delta x plus k of x plus delta x minus k of x over delta x, right? We can do that. And now we have the limit. Sorry about that. Well, what does this look like? The limit as delta x goes to 0 of this is the derivative of g of x, right? And the limit as delta x goes to 0 of k of x, in this case it's this whole term, is the derivative of k of x, right? So we just proved it. If we have y is equal to delta g, is equal to g of x plus k of x, then the derivative of y is equal to the derivative of g of x plus the derivative of k of x. Now let's take an example from the book, and I'll show you how to solve it. Let's say you had page 43. Page 43, example 1, y is equal to x to the power of 5 plus x to the power of 4 plus x. And they're telling you, find the derivative, find dy dx. Well, we can find the derivative of x to the power of 5 plus the derivative of x to the power of 4 using the addition rule I just showed you, dx, right? Using the power rule, this is 5x to the power of 4, right? Let's restate the power rule. X to the power of n, the derivative of x to the power of n is equal to n x to the n minus 1. This is going to be equal to 4x to the power of 3. And well, here it's x to the power of 1, right? So we remove 1 outside and we say x to the power of 1 minus 1, which is the same thing as saying x to the power of 0, which is the same thing as saying 1, right? And this is the derivative. So now, and guys, it can be proven if we have y is equal to g of x minus k of x, then the derivative, now if we have a minus, it's just going to be the same thing. It's going to be the derivative of g of x minus the derivative of k of x. It could be proven. I don't need to prove it because I already showed you how to prove the sum rule, so the difference rule is the same fashion. Now guys, if we have a derivative y, if we have a function y, and y is equal to 3x, for example, or 3x squared, 3x squared, right? And we want to find the derivative, which is dy over dx. Well, we can actually factor out the constant, and we can find the derivative of x squared with respect to x. And if you want, I'll show you the proof of that in a second. And it's just going to be 2x, and it's going to be 6x. That's the derivative of 3x squared. So let me show you the proof of that. We said that the derivative of a function, this is the limit, this is the definition of the derivative, right? Let's rewrite it again. And we said we have a function y which is equal to, let's say, kx squared, for example. K is a constant, so k is a number. We're going to be treating k as a number. Okay? K is a normal number, it's not a variable. In fact, let k be 4. Okay, let k be 4 so you guys won't get confused. And let's just, let's just put in the numbers. So yeah, f of x plus delta x is equal to 4 multiplied by x plus delta x, right? So let's factor in these things. And f of x plus delta x is basically 4x plus delta x all squared, right? Sorry about this. Okay, minus. And f of x is 4x squared, right? Over delta x. Now, as you can see, we have 4 here and 4 here, so we can factor it out. Delta x squared minus x squared over delta x. And we have a limit as x goes to 0. Now, what did we define this fraction to be? We defined this to be the derivative of delta x, right guys? And we have a 4 outside, so we simply just multiply it. And I just proved it. If you have a function y and it's equal to, let's say, 4x squared, then the derivative of y is going to be equal to 4 multiplied by the derivative of x squared dx. And that was the general idea of the derivative. And now I'm just going to do some simple exercises. Maybe you guys will get, will get more familiar with this derivative thing. Let's do example 2, page 44. Y is equal to 5x cubed, right? So the derivative of y is going to be equal to 5 multiplied by the derivative of x cubed dx, right? Now, using the power rule, the derivative of this, using the power rule, the derivative of x cubed is 3x squared, and we multiplied by the 5. So dy dx is equal to 15x squared, right? And you can check the back of the book, and the answer must be correct. Now let me do a polynomial question. It's like, let's just pick randomly from the book. Let's pick randomly from the book. Let's say I'm doing example 4b. Example 4b, y is equal to 4x to the power of 6 minus 3x cubed plus 5, right? And we want to find dy dx. Well, it's the sum rule, or the difference rule in this case, and it's going to be the derivative of 4x to the power of 6 minus the derivative of 3x cubed, or dx, and plus the derivative of 5 dx, right? So what can we do here? We can factor out the 4, and we can say the derivative of x to the power of 6 dx, right? And I showed you how. Same thing with this, and nothing happens to d5 dx. Now, we can use the power rule, and we can say it's 4 multiplied by 6 x to the power of 5 minus 3 multiplied by 3x squared, right guys? Plus, and now we need to find this. Now the derivative of 5 with dx, or the derivative of any number, the derivative of, let's say, k, and k is a constant. K is a constant. What's the derivative of a constant? Well, what is a constant? If we were to graph a constant, let's say 5, would be a straight horizontal line. Now the slope of a horizontal line is always equal to 0, and by our definition the derivative is the slope. So the derivative of a constant is equal to 0. So yeah, this is equal to 0, and we can evaluate it. It's going to be 24x to the power of 5 minus 9x squared. Let's do one more example, or actually let's do one more activity before I end this video. Let's do activity 1, page 45. 1c, first of all, let's do 1c, and let's do 2a, right? So 1c tells you that you have x squared, y is equal to x squared over the fifth root, or the cube root of 5x, right? So we can rewrite this as x squared multiplied by 5x raised to the power of minus 1 over 3. Right, guys? So now how might we solve this? Let me actually rewrite it in another way, in a more understandable way for you guys. It's the same way as saying x squared over the cube root of 5 multiplied by the cube root of x, right? We can do that. It's a property of radicals. So now we have x squared over the cube root of x multiplied by a constant. The cube root of 5 is a constant, right? And we want to find dy dx. So we can find the derivative of this, which is dx squared, the cube root x dx. And we can multiply it by the constant in the end, right? Now let's find this. Now x squared over the cube root of x is the same thing as saying x squared multiplied by x to the power of negative 1 over 3. You guys should know this, grade 7. 2 minus 1 over 3. And it's the same thing as saying x to the power of 5 over 3, right? So this is x to the power of 5 over 3. We multiply it by 1 over the cube root of 5. And that would be your derivative. So now, let's do our last example, which is 2a. Y is equal to minus 5x to the power of 5 plus 2x to the power of 4 minus 6x squared plus x minus 2, right? Now, we don't need to write derivative and everything in the exam, so let's just do it mentally. It's going to be minus 5 multiplied by 5x to the power of 4, right? Now you guys have gotten used to it, probably, by 2x, plus the derivative of x is 1, and the derivative of a constant is, well, 0, as we said, right? And we can, evaluate this. And yeah, now you've learned how to find the derivative of any function. Thank you guys for watching, and as always, easy.